base default HyperX Quadcast. Hello, 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 hello. I think you can hear me now, right? Sorry for that. Should have checked the microphone, obviously. And let's see. I hope you are receiving me now. So what I told you just now was that yeah, I'm going to take a look at the sun. So with my with my Daystar Quark again. So let me also change the setup I'm using. You can see again not a perfect clear sky. I'm in the Netherlands, and yeah, we always have some haze in the daytime sky. So you can see a lot of wobbling going on, but at least we have a nice live view of the sun. Let me change the setup because I need, of course, to add that I'm using the Daystar Quark Chromosphere filter, solar filter. Yeah, Daystar Quark Chromosphere, which gives you a hydrogen alpha look at the sun for those of you who are interested in the gear I'm using. And why is that important? Well, it is why would that be interesting? It is interesting because we can take a look at the chromosphere, and the chromosphere is actually the less bright part, a separate layer actually of the sun. We are used to looking, yeah, you shouldn't look at the sun, of course. Always wear these nice sunglasses. You can pick them up for €5 or dollars, and then you're fine. But this is a special telescope with a special Daystar Quark Chromosphere filter, which allows us telescope enthusiasts to take a look at the chromosphere layer of the sun. And that is interesting because you can see a lot of electromagnetic activity, sunspots, and also solar flares leaving the chromosphere. And the chromosphere is actually a layer that is on top of the photosphere. But actually, you can Google that. Anyway, hey, I can see cat's face, the cat face. James, good morning, James. €1,700. Yes, is that the current price of the Daystar Quark Chromosphere? I'm hoping not. I think I bought it for about 1,200, but inflation is terrible right now. And here we are at the sun. Yeah, I think is it a cat? But interestingly, there are 1, 2, 3, 4, 5, 6. I don't know. I can count like 12 different areas, sunspot areas. Maybe I can brighten the image a bit. No, maybe this. You like this view? Let me try to fine-tune it a bit. I think this is about the best I can get right now. Very interesting area, actually. So we could also check solar weather live to see if I'm sure these sunspots are also already documented, and we should be able to find them on the internet. But before doing so, I will take a 30-second picture here, if I'm able to. So I'm using SharpCap here as a capturing software. 30 seconds. We can actually name it as sun. And what is the 12th? Today is the 12th. 2022. Okay. Start. So I'm also drifting a little bit because, I'm not completely polar aligned. I just set up my telescope during the daytime, and I took a lucky guess on where the north is, and apparently I didn't do a very good job, but I was able to find the sun, and it's tracking the sun right now, so that's nice. Oh, we have a lot of drifting towards the right. That's unfortunate. Maybe I should reposition the mount. So let me go back. Let me take another 30-second picture, so that at least I already have these two sunspots. But oh, the drift is kind of terrible. Oh, it's buffering. 200 to go. I should also change the mini PC I'm using. It's a small desktop PC, but it doesn't have the quickest hard drive. It doesn't have an SSD hard drive. Hard disk, I have to say. Okay, so let me take another 30 seconds. Yeah. And then we will take a tour of the sun afterwards. And let me also look at... where is it? Here, Space Weather Live. Always a nice website to check out the activities on the sun today. And apparently we are here at 3141. Can you see it? Yeah. 3141. So and 3140 and 3145. I think this is the most active region on the sun right now. If I look at this intensity gram, it's called. Which shows different groups of sunspots. And 3141 is actually very active. Sunspot region reporting with 21 groups of sunspots, as you can see here. And I was also looking at the solar flare because we have a 75% of a C-class solar flare and a 25% chance of looking at an M-class solar flare today. So C-class and M-class are pretty nice solar flares to look at. Let's look at the data. And I saw also earlier this week, so this is the data from 3 days ago, or 24 hours ago, you see that the sun did show some peaking. Here an M-class solar flare, so the higher these peaks go, the bigger the flare is. Here another one on Saturday, during the night for me at least. And yeah, maybe we will see another one. I'm hoping for that to happen, of course, during a live stream. That would be nice to experience that with you guys. So let me go back to the view here. It's too expensive, the Daystar Quark. Yeah, the Daystar Quark Chromosphere is not the cheapest way to look at the sun, of course. A much cheaper way, if you are not able to pay for the Daystar Quark, is to just get a solar filter. Just solar filter, a telescope solar filter, look at the sun. You need to check out the brand. I personally use a Bader solar filter. And you can put it on a lot of refractors. And it will give you a look. You can take a look at those sunspots with a solar filter that costs about, what is it? Maybe 100 euros, something like that. So let's check out the edge of the sun. Let's increase the exposure here. We did see here, I skipped over it a little bit, but there is some here. I think this is interesting. We have these clouds here. They are not clouds, of course. They are, I think, hydrogen, helium, something, because the sun is mostly composed out of hydrogen and helium. So we do have some flaring going on here. So let us take a look at the rest of the edge. Trying to get my bearings here. Whoa. Here we have another nice, interesting, maybe, here we have it. Just 1 second. My children are pretty excited because today is a Sinterklaas day. Woo! That's pretty interesting here. Let's take a further look. So, some other flaring going on here. Not really M-class, I think. Here we have some activity. Very interesting, those flares. And of course, when a flare is really, really big and it is exactly aimed at the Earth, then we might experience some electromagnetic interference on Earth. So, small PC and big telescope is not good. Okay, why not? Why the telescope is shaking? It's not shaking. It is because we are zoomed in on the sun and the focal length is about 2000 millimeters. So the shaking you are referring to is actually the turbulence in the Earth's atmosphere right now. So I'm looking through a lot of air and the sun is not very high in the sky in November and December. So that's what causes the wobbling. Can you do a meteor shower live next, please? Okay, I will take a look at it. Munku. Hydrogen and helium, yummy, it's tasty. Yeah, I don't know. Okay, solar eclipse. I don't know what you're doing, but be nice to each other. Let's take another look at the disk here. So we don't see a lot of flaring. It's mostly at the top here on the low end. Yeah, there are some clouds here hanging. Let's see here. Yeah, it's pretty faint, but they are there. Let's see the rest of the disk. Okay. Hi to user. Bye bye, solar eclipse. Yeah, I'd like people to remain positive. Sorry for that. I don't need all these comments. Hey, now we don't see anything else, I think. This is where we started out. It's pretty cool though, I think. It's pretty cool. Okay, my children are singing, so you might hear that. Yeah, that's pretty cool solar flare. But it isn't being reported. Maybe are they just then the remnants of that big M-class flare that is reported? So when we look at this website, let's see. Can we actually see the activity for the past hours? I don't think they have a they have a video, I think also. It's not running. Okay. But when we look at this data sheet here, there was here, it's only about 12 hours ago we had some nice big solar flares apparently. So we might be looking at the remnants of that solar flare here. Could be, I don't know. Marvel. Am I a Marvel fan? Nah, I'm not against Marvel. I'm not a big Marvel fan, to be honest. I'm not looking at Marvel. I'm looking at a live view of the sun, and this I've also found this interesting, right? These, yeah, you can hardly see it. So when I really overexpose it, you can see here this big flare going into space, being released, I guess, from the sun. Pretty cool. So science fiction is nice, but my hobby is real-time astronomy and astrophotography. So here we are. And two others. I think this is about it. Yeah, I want to take... Oh no, there was one big one, eh? One other one, I think. Oh, yeah, they are exactly the opposite way. Wasn't there also a big flare going on here? Yeah, that's pretty cool. But I think I saw these before, actually. I think 4 or 5 days ago I saw the same kind of structure, the same kind of flare. So I'm guessing these flares are bound to the sun. I don't think they are these quick like releases of flares into space. But so yeah, I need to read up on the sun a lot. So I think these are actually, I think they've been here for a week now. They changed. They changed in appearance a little bit, but not too much. I could try to find a picture so you can see what I already produced or what kind of picture I already took. So yeah, I will take a short video here. Ah, the wobbling is terrible. Yeah, there is a lot of turbulence, and also there are some clouds hanging in front of the sun. So this is definitely not an optimal view. But if I have to wait for an optimal view in the Netherlands, I can wait until I'm 100 years old. So, yeah. Let me just quickly go outside and check the haze in front of the sun. Yeah, it's definitely some haze in front of the sun. Why the flames move so slow? Yeah, I need an astronomer with my live streams to explain that. But my guess is oxidized, and please correct me if I'm wrong, or if you find any other explanation on the internet, is that some of those, it takes a lot of effort or energy for those flares actually to be released from the sun. That's what I've read, I think. And so a lot of these flares, they are in the chromosphere and they're trying to get out, but they are still bound by all the electromagnetic activity that's going on the sun. So I think these are not exactly flares that actually leave the sun and move into space. So I think they're still somewhat bound to the sun's gravity or electromagnetic activity. So if anyone wants to comment on that, please do, because I do see a difference between some of these flares like this one. Oh, was it here somewhere? Here, this maybe, which looks like it is loose, like it's actually kind of leaving the sun, I think. And we have these bound kind of flaring that I already showed you. But it would be nice if anyone wants to tune in during a live stream, a person that is more knowledgeable than the astrophotographer you're talking to now. That would be great. So I do also like this area where we have a lot of sunspot activity. And the immense big thing. You mean the sunspots, I think. Do you mean this? So those are sunspots on the sun, and the dark areas are actually a little bit cooler than the rest of the sun. And you can see here, there's a lot of fluctuation in electromagnetic activity and temperature. And I think these kinds of activities actually cause solar flares to happen. And how big are they? Yeah, they're pretty big because, I think in diameter, the sun can fit 109 Earths in its diameter, so from left to right. So that's already super big, and we are looking at a small fraction of the sun now. Because I'm really zoomed in here, you can see this is not even, I think about, you could, if this would be like 50% of the sun, from left to right, you could already line up about 55 Earths. So one of these sunspot areas is already as big as the diameter of the Earth, I think, and which is about 18,000, 19,000 kilometers, I think. Oh, these are definitely clouds. Clouds, you can see it like the sunspots become unclear, then they become clear again. So that is the haze hanging in front of the sun. The bigger object, the slower things we see from here. Okay, so you are, I think, then talking about the solar flare here. But the same goes if you look at, if you're talking about size, you might refer to this flare. So this is a pretty big one. You could easily line up maybe 10 or 15 Earths, I think. And here we have another big. It's not super big, but here we see some flaring. Yeah, I mean, yeah, easily the diameter of the Earth. Nothing but clouds in London. That's unfortunate, James. James, are you knowledgeable? Do you want to tune in sometime to explain people what we are looking at? Let's see. I do like. I think I will hang around because there's a bit of haze, but I think it will be getting better, the weather. So let me check out the weather quickly so you can see where I am. Properties. It's this one. Okay. F5. So let's refresh. Oh yeah, and let's also zoom out so we can see. So James, if you're in London, then indeed you will experience some clouds. This is the Dutch time, of course. So I guess you are 1 hour behind. So it's 9:15 in London, I think. So it's, or maybe it's 11 in London right now. Yeah. So this is the actual radar satellite images. So I am here in Utrecht, the Netherlands. And as you can see, it's relatively clear, but yeah, it's not getting better because you can see here, this haze is now moving in front of the sun. So that's what I am experiencing in the videos I'm showing you right now. So here it's wobbling a lot, but oh, now we have a bit of a clearer picture, I think. So, but the wobbling is definitely the haze in front of the clouds, like the hazy clouds. Can you say that? In front of the sun, in combination with the fact that the sun is pretty low in the sky right now. So I have to shoot through a lot of air and atmosphere to actually get an image of the sun. So that's what happens. So let me take another short video. Oh, I'm drifting a lot. That's the way it is. So maybe a bit like this. Start capture. Yep. So I'm drifting towards the right. I could try to make a minor correction to the mount. Let's see. So what is it? South north. Okay. So I'm drifting towards the north, apparently. So I could try to make a small correction. You know what? I will do that tonight. So because the weather here in the Netherlands today was it's just lucky that we can see the sun right now. Because tonight it will be cloudy again. And I saw maybe Sunday evening it will be clearer. So I might be back on Sunday evening with a live stream of the planets. So let me also try to catch the flares that I've seen. They were here, right? Maybe we should overexpose. They're pretty faint. They're pretty faint. Oh, yeah. These ones. I think they are kind of leftovers maybe from the M-class flare. I don't know. Kind of spooky. And next week. And next week. That is a bit unpredictable. I hope it will. We will have some clear skies in the Netherlands again. But my experience over the past couple of years doing astrophotography and planetary imaging is that generally from November until the end of February, we will of course have some clear skies, but to have an entire clear night here in the Netherlands, or I think for that matter also in the UK or Scotland, it's kind of rare. Most of the time you will have some clouds in the air. So that's also why I'm doing these live streams. How do you call that? The atmosphere is too bad right now to take long exposure pictures, but we can still take a look at objects in the solar system. And I think that's also pretty fascinating, because you can take live videos and see things change over time. So I'm also going to take another video of these flares here. So I'm doing this in SharpCap. I'm just making these 30-second videos, and I have my frame rate is terrible, 23. Yeah, it is because I have a large capturing area, and I'm using a camera that has a small pixel size. Anyway, maybe I should try to make a small correction to the mount. I'm going to try to do that. No. Actually, today is the day that Santa Claus, for a little, it's like the Santa Claus of the Netherlands. He arrives by boat in the Netherlands, and my kids are now watching the ship coming into the harbor. And they always make a lot of fun, and there are also a lot of stories always that the boat is missing, or the boat was, I think the story of this time was that the boat did actually sink to the bottom of the ocean. I thought that was kind of harsh to tell the children. But anyway, it always turns out all right, and Sinterklaas will give the children of the Netherlands a big surprise. Like what you call Christmas Day actually happens in the Netherlands on the 5th of December. So all the children will get presents. Anyway. So I might also be able to process these images I'm getting. Let's take another tour and see if anything changed in the meanwhile. Let's first take a look at the disk again. Nah. Let's go down. It's about the same. We have some flaring here. Dun, dun, dun. Also a little bit of flaring here. And then these ones, yeah. So let me take another video of these flares here. Up. Up. Yeah, drifting. Start capture. So pretty cool. Kind of a Christmas tree, I think, here. Huh? So apparently, yeah, these I'm sure that these flares, they were here before. So let's take another look at Space Weather Live, see if anything has changed. I don't think so. I'm still waiting for the first time I will be able to catch an M-class flare, and there is a probability of 25% happening of it happening today. So yeah, I'm still hoping for a nice big flare to catch. And yeah, this is the most active sunspot region. So let's take another look at that sunspot region. Which is kind of cool. Oh, did I miss it? Here it is. So I do know that the sun currently is in an upward cycle in terms of activity. So we should be able to get more and more, to view more and more sunspots and solar flares for the upcoming years. So let me try to adjust the exposure a bit. This is not... So it's always a challenge to correctly balance. Yeah, it's about 70%. And if I up the gain a bit, 80%. Oh. I think this is as far as I can go before really blocking out. Maybe I should stay at 70%. I'm not sure. Right. Sunspots. Pretty cool. Let me give you the full view here. So, what do you think? Technoblade says hi. Hi, Technoblade. We're looking at some sunspots on the moon live right now. Oh. And start. I'll take another capture here. So how many frames did I take? 2000. Oh, that's pretty good. Start. Let's do it again. Yeah, Technoblade, we are looking at the sun. So this is a really zoomed in image of the sun. I'm using about 500 millimeters of focal length, but I also use the Daystar Quark Chromosphere filter to actually see the chromosphere layer of the sun. So that's what we are looking at. And so the Daystar Quark solar filter has a magnification of 4 times the view you would be normally getting with your telescope. So we are looking at about 2000 millimeters focal length. So you can see that we are only looking at a part of the sun, about, 25% or maybe even less, with the Daystar Quark. But that also allows us to really zoom in on the sunspots and solar flares, so that's pretty cool. Oh, you made a cap out of your 3D printer, Oxygize. That's pretty good. So Oxygize, that is, I think you will have detailed views of the sun, but you're not looking at the same layer if you're using a solar filter. So I also use the solar filter for the partial solar eclipse that we were able to see in the Netherlands. That I also use the solar filter and not the Daystar Quark because I wanted to capture the entire disk of the sun. And so you do have a good picture of the sun that way, but you will be looking at the photosphere layer instead of the chromosphere layer. And the photosphere layer is also a bit granular, but it's much brighter in comparison to the chromosphere layer, and also much hotter. So you will be able to see sunspots with the solar filter, with a regular solar filter in front of your telescope. But you won't be able to see all that electromagnetic activity I'm showing you that's going on in the chromosphere layer, just because the photosphere layer is outshining actually the chromosphere layer. Anyway, I hope you understand what I mean. Right, I will also capture these flares. They're pretty nice. I think I will not be able to catch the disk because I have to choose for either the flares or, here you can see it, when you can see the chromosphere layer of the sun, I can't capture the flares and vice versa. So let me do it like this, overexpose the surface, or at least the chromosphere layer. It's not really a surface of course on which you can walk. Okay, let's start the capture again. Poof. So it looks like these kind of flares are kind of leaving. So we have, I know that we have at least 3 layers of the sun. The photosphere, which is very hot, it's the inside of the sun. Then we have the chromosphere, where temperatures apparently cool down. And we have a lot of electromagnetic activity, sunspots and solar flares. Plasma, basically, trying to leave the sun. And then we also have the corona, of course. And we can't see the corona right now. The only way to see it is actually to wait for a solar eclipse. And there will not be one in Europe for the next couple of years, but there is one, I think, next year in Australia. So yeah, if you want to go to Australia to see a solar eclipse next year, you can. You can. So I think this is about it. Let me take another tour. I'm still hoping for that one flare to show up, that big explosion. Yeah, definitely some flaring here. Yeah, it showed a 25% chance of an C-class flare today, so... Or 75. And 25% chance of an M-class flare. Nothing changed. There's a bit of activity going on here, but not too much. All right, let's go back. Do you see anything? Most of it is still on top, or at least on top for the way I positioned my own camera. So here we have, this is, I still like it. It is cool to see these flares. Here we definitely have some flaring. Let me take another 30-second video. Kind of cool. So we're looking at a live view of some solar flares on the sun today. For those of you who tuned in a little bit later. So I'm taking also some videos of it so I can process them into pictures later on. And all right. Oh, 938 frames. Can I speed it up a bit? Yeah, I should be able to zoom in. Strange camera, this 678. It has like smartphone positions. The horizontal 1920 here. This is better, I think. Let's see. Let's increase the. Oh, we're leaving the sun again. Let me get the sun back into view. So here, let's try to focus more on these flares. See what happens. Nah. 2 times. So I'm also looking at some binning options. Nah. Nah. That's not what we want. 2 times. This is kind of okay. Oh, drifting again. So my FPS goes up a lot when I limit the capturing area, my frames per second. And that's interesting because then you can take more pictures basically. That's what I'm looking for, taking more pictures of the sun. But I get these kind of... Oh, it's like the 678 is more aimed towards taking smartphone pictures. Interesting. Can I then turn this view? Yeah, I can flip the view, but not the way the sharp cap. Yeah, it's like 1920 by 2140. So maybe just go for a squared view. That would maybe be best. This is not a squared view, right? Maybe it is. 50%. Can you see it like this? Yeah, a little bit, huh? Maybe put it at 125 and then like this. So this is really a zoomed in image. So let me try and take a picture of a little bit. I'm trying to capture the surface and the flares here. Oh, look at the turbulence. So let's take another 30-second capture. So my frames per second now increased to 63, and that's actually pretty good. Because I limited the capturing area a bit to 2160 by 2160 pixels. So yeah, 1904 frames captured. So that's a lot better. Maybe I should do auto. But I'm a bit afraid that you are not getting the best view then. Let me check. Yeah, it's a bit strange. So this is the capturing area here. 4000 by 2000 more or less. That gives us a nice full view of the sun. But when I want to capture these details, because of the resolution, the high resolution and the small pixel size, my frames per second are dropping. Oh, now it's better. Oh, look at these sunspots areas. Now we're getting a much better view than compared to when we just started the live stream. I'm getting excited about that. Yeah. Oh no, do not wobble. Stop wobbling. Let me try and position them a little bit towards the right, because I know I'm drifting. Oops. Something like this. And let's start the capture again. Pretty cool. So let me also take a look at my weather. This is not my weather. My actual clouds here. Let me check. Let me check with F5 what's going on here. So this is the latest picture. Maybe we are lucky. So let's check out the cloud radar. Yeah. You can see, if you look at it closely, you can see here these small hazy clouds moving in front of the sun, basically. The sun is here now in the south for me, because it's about 1 o'clock, 1:45. And we should, I was hoping for this kind of patch, like a really clear patch of sky. But what we are getting is a bit of haze, but still we are able to see something of the sun. So something is better than nothing. And we do have these cool sunspots, so I'm already happy with that. Let me go back south. Let me take and reposition those sunspots, and let me take another video. I really like this area. It's interesting. Pleasing to the eye. Start. So yeah, trying to get the most out of my astronomy these days. Especially during winter time, November, December, January, they're supposed to be the best times on the one hand, because we have, of course, in the Northern Hemisphere, we have long nights. But at the same time, we have we have a lot of clouds here in Northwestern Europe. So yeah, it's a bit tricky. Sometimes you get if it gets really cold, then we might have one or two nights of clear skies. Then definitely I'm going to try to image some deep sky objects again. But as it stands right now, we have like 1 or 2 hours of clear skies. That's also great, but then it's nice to also focus on the solar system, the sun, the moon, the planets. Because you don't need a very long exposure time, you are taking short exposure videos basically to capture these solar system objects. Well, this is cool. So what are we actually looking at? I can show you the Space Weather Live information. So here it says that especially 3141 is the most active region, I would guess. It's also red, so that's an indicator. And it shows a beta, gamma, and this is a sigma sign. That is some kind of classification of that sunspot. Yeah, I can only show you this. So today's sun, 57 sunspots reported. Or sunspot regions, I think, reported. There are 0 new regions, so they were here also yesterday. Radio flux is down by 1 point. The Carrington radiation is at 2264. But can we actually, because this is not here, this is the, I really have to get more knowledgeable about. Here, region 3141. That's what we are looking at. So, yeah, what can we see? Oh, it shows in that region C-class activity is 80% probable. Ah, so if I interpret this correctly, the solar flare probability says. So solar flares are most likely then to happen around these sunspots. That would make sense, I think, because there's a lot of electromagnetic activity going on. So then, of course, it will also produce a flare. Okay, I'm learning here. Hope you bear with me on that. Yeah, cool. So the sunspots are also the areas where a solar flare is most likely to happen. I think that's what I learned today. And if you know more, then put it in the chat. Oh, this is a cool area. I'm going to capture this a couple of times because should I zoom in a little bit? Let's do this, see what happens. Yeah, I'm trying, because my frames are now per second are higher. So that means that I can take more pictures basically in a 30-second video, which I will be able to process. On the other hand, I'm experiencing quite some drifting. So I don't have a fixed spot to put my mount, not yet. I was actually thinking about buying like an expensive cover for the mount so I can put my mount, or leave my mount outside for the whole year. But I'm a little bit hesitating because it's a pretty expensive piece of equipment. Yeah, let's, you can see a lot of wobbling, eh? So is what kind of picture am I broadcasting? Okay. Maybe I can zoom in a little bit, 125 like this. So you have a full image. You can see the drifting now also. Oh, you can't see my frames per second. So I'm now at 70 frames per second, but you can see we're drifting towards the left. Towards the right, actually. So the picture is moving left. Yeah, that's cool. So now I can capture about 3000 frames in 30 seconds. That's what I was looking for, but unfortunately I'm not polar aligned, so I'm drifting. Should I try to fix it? I think I'm afraid that I will lose the sun and I will have to find it again when I'm making these small corrections. Yeah. Well, maybe I should try anyway. I will go outside and try to reposition my mounts. So I think it's, yeah, I need a bit of sky here. Okay, let me try to do that. So guys, bear with me. I'm trying to calibrate my mount. I hope I will get it back. Yeah, here we go again. I'm trying to eliminate the drifting we are experiencing. All right. Go south again. It's always tricky to calibrate your mount during the day. It's still moving. Nah. Okay. So one last try. I definitely think I did not solve my problem. This is getting a bit worse. Oh, sun, come back, please. So let's see what happens. I'm still drifting. It did not change a lot. Interesting. So I'm drifting towards the south. So I thought by repositioning the north-south axis, I would be in a better position, but apparently we are still drifting. No. I don't think it is better now. Maybe one more time. So I will leave it at this. Let me go back. Let's see if anything has changed. So, no, not really. We're still drifting too much. That's unfortunate. Yeah, it is what it is. So, okay, let me take another tour. So, let's check it out here. How long have I been broadcasting? I think about an hour. Vic is here. Hey, Wido. Hey, Vic. George also just entered the chat. Hello, everyone. Georg or George? Oh, I think I asked that the last time I saw you. Thanks for joining. We are obviously taking a live view at the sun today. And I'm experiencing a little bit of drifting in my mount. I tried to correct for it, but I didn't do a very good job, I think. So let me once again, for those of you who tuned in a little bit later, to show you, I will show you first the edge of the disk of the sun. And we do have some flaring going on. First we have these, I would say, these three little trees here. And actually I saw them before. I saw them, I think, about 5 or 6 days ago. That was the last time when I looked at the sun. And so these, apparently these flares here, they are here to stay. They are not really leaving the sun or anything. They are, I think, bound by the magnetic activity of the sun. But still nice to look at. Look a little bit like trees in a forest. So let's go down. Let's see if there are any new activities here. So I'm overexposing the disk to look at the flaring around the sun. Here we have super small flares. Yeah. I'm always hoping to see this. There will be a day in a live stream where we do get to see a super big solar flare. I promise you. I will not stop broadcasting before that happens. Yeah, nice, but still pretty small solar flares here on the edge of the disk on the bottom of the sun, or at least the bottom that I am showing you. There is no real bottom, of course. Or maybe, yeah, here we have some faint, I think they are remnants of a bigger flare that are still kind of visible. Okay, I really have to overexpose it. We can see here, 1, 2. There is definitely some flaring going on here. And then here on top we have, I think, a couple of other ones. Here, as you can see. So now we're back on top. It looks like a flare that has already happened, more or less. And when I'm looking at Space Weather Live, here, I can actually see that there was an M-class solar flare earlier on today, just after midnight for me. So if I look at this data here, the past 24 hours I'm showing you now, you can see that there was a peak here about 12 hours ago. And also another peak, definitely a C-class solar flare. And this one was, I think, actually an M-class. About, yeah, half a day ago. And we do have the prediction here that we can see some C-class solar flares and 1 out of 4 chance to see an M-class solar flare. So I was hoping to show you that. It is kind of cool to see this, right? But I think when we look at the most recent data, if I can trust this website, is that we are back to here. The last 2 hours have been pretty quiet, as you can see. So yeah. And we do have this super nice solar region, solar spot, or solar spot area, I guess. For those of you who tuned in later, that's here. It's pretty cool to watch. Let me try to give you a good view. So here we have it. Pretty cool groups of sunspots. I would also guess that maybe here there's a high probability for solar flares to occur. So yeah, pretty cool here. Yeah, unfortunately I'm still experiencing the same kind of drifting. Okay. I need to update my shop cap, I think. No matter, but we are still drifting. I didn't fix the problem, yeah. So probably I should make the correction the other way around. But anyway, we do see some nice sunspots, so I'm really happy with this. And yeah, Georg, yeah, again, yeah, Georg, sorry. The German pronunciation rules have to be applied. I think Georg would be in the Dutch, it would be Georg. We have like this strong G sound in the Netherlands, which sounds like persons who are spitting or, anyway, Georg. Hannes then also probably. So I think I will still try to, because the drifting got worse, so I think I made a wrong correction. And I will go for final time outside to correct this drifting. So we'll hopefully get a better stable view. So bear with me. Drifting, it's still drifting. Okay. Let's go back to these sunspots. Still drifting. Right. We are still drifting. Okay. So not bother you with that, I think. Let's see, it didn't really change. So here we have the beautiful sunspots. This is definitely the highlight of the day. Still moving towards the left. Strange. Anyway, I will not bother you with that anymore. I use a white filter on my telescope. Jason Cox says, when I see the sun in Shepton Mallet, Somerset, England. Yes, Jason, that's perfect. I think I didn't. I bought a very expensive Daystar Quark Chromosphere that I'm showing you right now, which gives you the opportunity to look at the chromosphere layer of the sun. But of course, I would highly recommend when you just start out using a telescope and you don't want to pay like these crazy expensive amounts of money to watch the sun. Just buy a good quality solar filter, like a Wido solar filter. So there are a lot of wide filters, solar filters out there that you can use in combination, especially with a refractor telescope. And that gives you a perfect look at, will give you a very nice look at the sun and the sunspots also. So you will definitely be able to pick up these sunspots I'm showing you right now. And the only thing that is different is that, when I reduce the exposure here, you can see a lot of, what did I do? You can see a lot of electromagnetic activity going on the sun. So that is actually the sun's chromosphere you're not able to catch with a regular solar filter. But apart from that, it's pretty cool to use a solar filter. And they only cost, I would say, maybe 100 or 200 euros or dollars or pounds. We are all about the same right now, okay? I think the US dollar is about €1 and the euro is about the same as the British pound. So maybe we should just do away with all of these fluctuations. Anyway, this is, I think, the nicest thing we are still able to look at. I will try to take another capture here. And there's definitely also some haze in front of the clouds, unfortunately. Oh. Maybe I will overexpose it a little bit like this. Maybe tune down. So the capturing area can be reduced. Maybe like this. Yep. Okay. Let's go up again. Let's go down again. Yeah, the tracking is pretty bad. Start. I just put my mount into roughly the north position, and I hope for the best. Already happy to have found the sun actually in the sky, but the tracking is not optimal. You can see that we are drifting towards the right edge of the sun, which is not good for taking videos. But it doesn't matter so much for a live view. So we have a lot of groups of sunspots. Apparently, what did I see? So let me show you this again. So this is the live sunspots we're looking at is 3,141. They just keep on counting, I guess. Will they start anew in the next year? I don't know. So is this 3,145 sunspots reported this year? I don't know. But 3141 is the most active one. So when we actually look at the data, 3141, you can see here, number of sunspots are 18, down from 21. The size is 740. What is that size? 740. Oh, here. The area of sun is expressed in millionth of solar. What? Corresponding to 3,043 million square kilometers. Okay. So why didn't they just do 1,000 square kilometers? Okay. Can I interpret this? Oh, here we have Earth. Ah, finally. So they did it for us. So you can see here the... Can I zoom in here? This picture, I cannot click on it. Oh. Here. Can you see it? So this is the Earth. And these are the sunspots we are looking at. So for you can see that this particular sunspot area here is bigger than the Earth, basically, in diameter. Okay, that's a nice picture. I should remember. I hope to remember that for the next live stream. So as you can see, we are drifting, drifting away. Let's go back. So it's actually this particular sunspot is bigger than the diameter of the Earth. And I do know that the diameter of the Earth is about 18,000 something kilometers, right? So this is the diameter of this particular sunspot, or is it this one? Oh, you can still see the haze in front of. You can see the picture is deteriorating because of the clouds in front of the sun. Ooh. Let's try to get a better picture. Or maybe like this. So this would be the biggest one, right? On the right, I think. So that's more than the diameter is over 20,000 kilometers, which is in miles. I don't know. It's like 1,200 miles, 12,000 miles, 14,000 miles. It's big. That's basically the message. It's pretty big. So no chatting. I hope you find it interesting enough. Yeah. Oh, let me... Chop. So okay guys, I'm going to do a final round here of the sun. So let's check one more time the edge. I'm hoping for like I'm hoping for a sudden outburst. Let's increase the exposure again. And let's look for some flaring. And of course we start here. There's already some flaring here. It's pretty faint, but you can see it. Let's do another tour. Am I showing you the picture? Yeah. No. So we do also have some flaring over here. Pretty faint, but it is there. It's there. And here we have the three trees, as I call them. They are here for at least a week now. These three here. Pretty cool to watch. But apparently they are bound to the sun's gravity still, I think. Or electromagnetic activity, because they do not appear to leave the... Is it the atmosphere of the sun? Yeah. The diameter is 12,742 kilometers, Georg. Thank you for looking at that. So the 18,000 was a bit overstating. It's 12 or about 13,000 kilometers. So that's okay. So then when we go back to this particular website, and we click on this. No, where did I... Oh, how did I get to that particular piece of information? It was somewhere he reported with. Still trying to find out how this works. Where was it? Information maybe? No. Nope. There was a particular picture with the Earth in the number of sunspots. Oh yeah, size. Maybe size. Here, this. So the Earth is 13,000 kilometers or 12,000 something, 800 kilometers. And that would be about the size of this sunspot, right? Okay. Thank you, Georg, for giving me the diameter. Can we see other solar flares popping up? Not really. It's relatively quiet. Some flaring going on here, but not too much. Here, small ones. Here we do have some flaring again, but not a really high and active one. Let's go back. Oh, this is a nice one. Yeah, we already saw it. Yeah, this is where we started. Sometimes I surprise myself and I think, oh, this is a new one, but no, we started here. This area. Let me do another capture. Although we are drifting. So this is about all we can see. I could try to process the sunspot video I just made. Uh, 125 to give you the full view. Let's go back to these sunspots. Here they are. Pretty nice. Start. Yeah, lots of wobbling. Captured. So I do have a couple of suboptimal videos. Yeah, I think this is it, right? There's also not... Let's look at the disk itself. Is there another sunspot? It didn't actually show on the map. So let's look for activity on the surface of the sun. I think the main attraction we just saw, the large area of sunspots. And maybe there's a new one, you never know. So, I don't know. Not really. If you see something here, these are interesting, these electromagnetic lines here. We need a physicist. Interesting slivers. So these might also actually be solar flares, with the difference that we are looking to in. Oh, these are definitely clouds, by the way. But I think we are looking at an edge-on view of these flares. I think. So whenever you see this, I think this is a solar flare. But we are hovering exactly above that solar flare, so we have an edge-on view, or like a top-down view of the flare. I think. It's an interesting place to see. Okay. Let's go north. The Chromosphere. So, of course, never look at the sun, but when you do buy some solar filter glasses, they are really €5 or dollars. So then you can, of course, safely look at the sun, and you will see the photosphere. And the photosphere is the brightest area of the sun, the brightest layer of the sun, where temperatures are much higher in comparison to the chromosphere, which is another layer of the sun we are looking at today. So temperatures are much more fluctuating, I have read, in the chromosphere layer of the sun. And there's much more visible, a lot of electromagnetic activity, and also solar flares that pop up that are trying to leave actually the sun through the chromosphere. But I don't see a lot of extra sunspots. Not really, right? Nah. This is it. This is it. The main attraction still is this area of sunspots. Here. And I also, if I understood correctly, the darker areas are also the cooler areas of the sun. Oh, a lot of wobbling. But we do see them. Trying to reposition them. They look cool. I was not able to compensate for the drifting of my mount, unfortunately. Maybe a final capture here. Yep, it is what it is. It is what it is. We do have clear skies, so I'm already happy for that. I could try to do a meridian flip, because the sun now is... Oh, what is that? So yeah, I'm pretty far... let's not bother you with that. trying to sync my mount. Current object. Sync. It's not responding. It is not responding. Okay. Whatever. So guys, I think yeah, we are not able to find any new solar flares, unfortunately. We did have a good look at these couple of sunspot areas today, which are the most active regions of the sun. And yeah, if you like these kind of live streams, please like the video and subscribe. I will try to get back I will try to be back with another live stream. For me, that would be Sunday evening in the Netherlands. Because they are predicting a couple of hours of clear skies. So I might be able to show you some planets, the moon, and perhaps some deep sky objects as well. So yeah, hope you like this quick live stream of the sun today. And I may see you again later. Bye-bye.